Hello everybody and welcome back to Pilot IQ on another question on performance graphs. Today we're looking at figure 1-8, time, distance, and field to climb, your PPL flight planning manual. Right, let's dive straight in. So the first thing we'll need to do, we'll have to take a look at the question, what we've been given. So here at the bottom left, I've written down the details they've given us in the question. So this is figure 1-8, time, distance, field to climb. The airfield elevation is 2,410 foot. QNH is 1010 hectopascals. The temperature on the ground is ISO. Then your cruising pressure altitude is 8,500 feet, and at that altitude the outside air temperature is -4 degrees Celsius. And they ask what fuel is used during the climb. Okay, so the first thing you'll need to do is make sure that you have figure 1-8 in front of you and that the title is correct, time, distance, and field to climb. It's actually quite easy to get mixed up with the different graphs they give you in the exam. So always double check that you have the correct figure and the correct title before you even start doing the question. Otherwise, you just might be wasting time on the incorrect graph. The next thing I read, the airfield elevation is 2,410 foot. But when I have a look at the graph in front of me, I see that I need pressure altitude to do the calculations. So I'll need to convert airfield elevation to pressure altitude. So to do that, I follow a pretty simple method. I say pressure altitude equals 1013 minus whatever the QNH is. I times that by 30 foot, since we know that 1 hectopascal equates to about 30 foot in altitude, and then you just plus the elevation. So if we just follow this formula, we can't go wrong. So 1013 minus the QNH they gave us on the ground was 1010. 1010 times 30 foot plus the elevation of 2,410 foot. So 1013 minus 1010 is 3 times 30 foot plus the elevation. It's 90 foot plus 2,410 foot, and that's an easy round 2,500 foot pressure altitude. Now this formula works very well because if you write the formula as 1013 minus whatever the QNH is, at the end of the day the sign will always be true for the correction factor. So in this case the sign was +3 and it gave us a positive +90 to add to the pressure altitude. So that checks out, since the QNH is lower than the datum pressure, therefore the pressure altitude must be higher than the airfield elevation. Right, so now we know what the pressure altitude is. Next thing we need to do then is figure out how much fuel we are going to use in the climb. So then the cruising pressure altitude that we are going to cruise at is 8,500 foot. And they also gave us an outside air temperature of -4 degrees Celsius. So follow me through on this green line over here. At the bottom we have -4 degrees Celsius, and then we draw a line straight up until we intersect with 8,500 foot, which is exactly between 8,000 and 9,000 foot. So the easiest way to do that, what I normally just do is I take a ruler and I measure the distance between the two lines, and I just halve that, and then I plot my dot right between the two of them. Once you have that plot, you go to the right, and then you'll see over here there's fuel in gallons, and this question is about the fuel to climb. So then we'll draw this line until we intersect with the fuel to climb, and then we make a plot and then move straight down all the way, and then we see we need 4 gallons to climb to 8,500 foot pressure altitude and the given temperature. So that climb is from sea level. So we know then from sea level up until 8,500 foot we will burn 4 gallons. But the question said that we are starting from an airfield which is above sea level, which is at 2,410 foot already, and we've just worked out that the pressure altitude is 2,500 foot. So we would save the fuel that we needed to climb to 2,500 foot already. So we then therefore need to subtract the fuel that we would have used to climb to 2,500 foot. So to do that, we'll see they give us, correction, we worked out earlier that we have a pressure altitude of 2,500 foot and that the temperature on the ground was ISA. So that's pretty straightforward. You'll see here's the standard temperature line on the graph. So all I need to do is plot exactly between 2,000 and 3,000 foot on the line over here, which will give me 2,500 foot on the ISA temperature. Again, I'll draw a line straight across until I intersect with the fuel to climb line, and I'll move down and I'll find the answer of 1. So we would have burned 1 gallon climbing from sea level to 2,500 foot. So what we just then do is take 4, which you would have used to climb to 8,500 foot, minus the 1 that we climbed to 2,500 foot. Therefore, from 2,500 foot to 8,500 foot climb will burn 3 US gallons. If you then have a look at the answer options, you'll see that one of the answers is exactly 3 US gallons. Therefore, 3 US gallons is the correct answer.